In this video, we shall introduce the asymptotes. So it turns out that your hyperbola follows a set of lines which are the asymptotes of your hyperbola. By now, you are probably done with discussing rational functions in your general mathematics. So you first saw asymptotes, vertical and horizontal asymptotes in your discussions of rational functions. So what is an asymptote? So the asymptote of a curve is a line whose perpendicular distance from the curve approaches zero. So this function, this is the graph of the function 2x over x minus 1. And as x approaches infinity, your curve approaches this line, in which case the perpendicular distance between the curve and the line approaches zero. It's the same when your x approaches negative infinity. The distance or vertical distance between this line, okay, and your curve also approaches zero. So in this example, this is a rational function. Your asymptote here is the line y is equal to 2. So we also have something like, we do have something such as asymptotes in a hyperbola. Okay, so for example, this one. So these are the pair of branches of your hyperbola, but its direction and width or narrowness is in fact defined by the angle between the two asymptotes. So these are the two asymptotes of your of this hyperbola. And so with this one. So last time I said that we will not use the focal width. You know what? If there is a focus here, if you were to draw a vertical line through the focus whose endpoints lie in the parabola, that is the latus rectum, and it defines the focal width of your hyperbola. That should be part of our information when we want to sketch the graph of a hyperbola. But last time, I told you that we will not use the focal width because we don't have to. Okay, at least for the level of grade 11 Precalculus, we don't have to. All we need is to draw these two asymptotes, and the angle between these two asymptotes will help us draw the curve of your hyperbola. Curve of your hyperbola will follow the direction of your asymptotes. In your hyperbola, we have the transverse axis. The length of that transverse axis is 2a. Okay, so that is the distance between the two vertices. And you have the conjugate axis with length 2b. Now, a and b, okay, so these values can be found in the denominators of your standard equation. These lengths, 2a and 2b, actually define a rectangle. Okay, and I will show that to you through an example. So let us look at this hyperbola in standard equation. So its vertex is, not the vertex, its center is at the origin. So this one is a hyperbola whose principal axis is horizontal, okay, because the term that follows or the term that comes after subtraction is y. And the denominator that comes after subtraction is also your b squared. So b squared here is equal to 1, which means b is equal to 1, a squared is 4, and a is equal to 2. Okay, so this is what I will do. We will plot your vertices and the endpoints of your conjugate axis using this information. A is equal to 2, b is equal to 1. So from the center, 2 to the right, okay, 2 counts from the right will give you 1 vertex. And 2 counts or 2 units from the left will give you another vertex. So this is your transverse axis, that line. Okay, how about B? The endpoints of your conjugate axis. Okay, so B is equal to 1. So you count 1 step above the center, that will give you 1 endpoint. And 1 step below the center will give you another point. So those 2 points define your conjugate axis. You know what? There is a rectangle that arises because of your transverse axis and conjugate axis. And I will show it to you. That one. And you know what? You can draw a line through the opposite non-adjacent vertices of your rectangle. The opposite corners. The opposite corners, non-adjacent corners. So you can draw one line through E and B and another line through A and D. Something like this. Okay, so these are actually the asymptotes that we are speaking about in this topic. And you know what? If I were now to graph the hyperbola, all I have to do is to start from the vertex and trace the arms of your hyperbola. And so that's it. That's going to be the sketch of the graph of your hyperbola. So we did it using only information about the orientation of your principal axis, the values of A and B. So what is the equation of those asymptotes? So when your hyperbola has center of the origin and its principal axis is horizontal, these are the asymptotes. You have two. One has a positive slope, the other has a negative slope. When I was in college, I don't like memorizing, okay? Because I get confused. Because we shall have another set of asymptotes when the principal axis is vertical. So it can be confusing. So what I did or what I would do is I will equate this equation or these terms to 0. Their difference is 0 and then solve for y. Okay? So solving for y, something like this will happen. If you were to get the square root of y squared, it will be y is equal to plus or minus b over a times x. So this would be a pair of asymptotes for your hyperbola when the center is at the origin and the principal axis is horizontal. How about when the principal axis is vertical? Okay, so these are the asymptotes. One has a positive slope, the other has a negative slope. And again, if you want to solve for the equations of these asymptotes, all you have to do is equate this to 0, solve for y. So the square root of y squared is plus or minus a over b times x. So this is the pair of asymptotes for your hyperbola with center of the origin and whose principal axis is vertical.